gravedad una fuerza física o simplemente una consecuencia geométrica? Is gravity a physical pull or a geometric consequence of reality? It is the most primitive question in physics. You drop a stone, it falls to the ground. For thousands of years, that silent action haunted humans. Ancient scholars observed this, concluding that objects fall because they possess a physical property called weight, and the earth pulls them because the ground is their natural resting place. This gap between what we see and what is actually happening suggests that our everyday perception of motion is only a surface-level interpretation of a much more complex, hidden underlying geometry. In the 17th century, Isaac Newton realized that the Earth wasn't a special natural resting place. He proposed that every single mass in the universe actively attracts every other mass. This equation is how he proved it.
The gravitational force between two things is determined by their respective masses and weakens dramatically over the square of the distance between them. The Earth pulls on you, but your body mathematically pulls back. The strength of this unification was its reach. The same equation that calculates an apple dropping predicts the planets orbiting the sun. One formula mapped the entire universe, yet Newton's equations contained a silent gap. How does the Earth pull the moon across 250,000 miles of empty space? There is no rope, there is no physical contact. Newton himself admitted, "I make no hypotheses." He had successfully mapped the precise mechanical output of the universe without ever identifying the engine driving it. In 1915, Albert Einstein arrived to fill that gap. He solved the problem of action at a distance by redefining the distance itself. His proposition was that gravity is a manifestation of geometry. To understand this, we have to look at space and time not as a stage where events happen, but as a single, woven, four-dimensional fabric that houses all existence. You often see this explained with a heavy ball resting on a stretched rubber sheet, creating a dimple that smaller balls roll into. Warning, that analogy uses gravity to explain gravity. Real space-time does not sag downward. It bends volumetrically, warping in all four dimensions at once. Mass doesn't reach out and pull you. Mass reshapes the invisible geometry of the room you are standing in. When you fall, you are trying to move in a perfectly straight line, but the Earth has curved the path of that line. This is why astronauts in orbit feel weightless. They are in continuous freefall, tracing a straight line through a curved universe. The physical sensation of being pulled to the ground is a byproduct of geometry. We are simply surfing the unseen topology of reality. Because gravity curves the unified fabric of spacetime, it alters the measurement of duration alongside distance. Massive objects create deep wells in the fabric, where time runs slower relative to the space far away from them. We measure this every day. GPS satellites are positioned high above the Earth's gravity well. Because time moves faster for them, their internal clocks must be actively corrected, or your location on the screen would drift by kilometers every single day. Pushed to the absolute extreme, this curvature reaches a breaking point. Pack enough mass into a dense enough point, and the space-time well becomes infinite, a black hole. Past the event horizon, space bends so violently inward that light paths are warped into closed loops. At the center lies the singularity, where our mathematical equations divide by zero and fail. These are not vacuum cleaners. They are the physical limit points of curvature. This scale compares the strength of gravity against the other fundamental forces, electromagnetism and the strong and weak nuclear forces. A cheap fridge magnet easily overpowers the entire gravitational mass of the Earth, yet gravity dominates the cosmos. Unlike electrical charges that can repel and cancel each other out, gravity only adds. Its power lies in its uncancelable, infinite reach across the dark. Here is the modern crisis. General relativity describes the movements of stars and galaxies. Quantum mechanics describes the vibrating world of atoms. When we try to use them together, the math self-destructs. We have no idea what gravity looks like at the subatomic level. We search for theoretical particles called gravitons to carry the force, but we can't find them. We build frameworks like string theory and loop quantum gravity, but none have been confirmed. The mathematical rules governing the rotation of galaxies disintegrate when we examine the most fundamental building blocks of matter. This friction has led to a radical hypothesis. that gravity is not a fundamental force, but rather an emergent property. Think of temperature. A single molecule doesn't have a temperature. Heat only emerges when trillions of molecules bounce off each other. Some physicists suspect gravity works the same way, emerging from the microscopic exchange of quantum information. If true, it recontextualizes the relationship between mass and space. Matter tells spacetime how to curve, and spacetime tells matter how to move. Newton saw it as a mechanical attraction. Einstein proved it was geometry. Modern researchers investigate the possibility that it is a physical manifestation of information exchange. You are not stuck to the Earth. You are moving through curved spacetime, caught in a relationship with the geometry around you. Gravity is the underlying rule that defines what together actually means.